Here are your solutions to 3-2, the guided practice problems. In problem number 1, we have a storage shed with a roof line like such. We have a rise of 3 feet, and it is 15 feet from front to back of the shed, and they want us to calculate the slope of the roof. So we would choose, in this case, rise over run. Real easy problem. The rise is 3 feet. The run is 15 feet. We could look at it like this, 3 feet, and then like this, 15, if that's the way you want to see it. Or we could use that. 3 over 15, we can divide both by 3, and we get 1 over 5. Or we could say that this is a negative 1/5. In this case, either of these would be correct, because you could look at it as a rising slope if you're down here, or you could look at it as a falling slope if you're up here. Either answer would be correct in this situation, but please be careful in some of these situations. Like for example, if we were doing this in a coordinate plane and here's our line, that must be a negative slope because we always read from left to right. But in this case, either answer is correct. Problem number 2. We have 2 points on a line. Again, it's one of those situations where you can just count the units, and we're going to use rise over run in this case. We'll talk about this in a minute. So we're going to count up 4 and over 3, so our slope is a rise of 4, run of 3, so our slope is 4/3. We could do this by calculating this point here and calculating this point here by looking at it, writing it in. We could use that either as a change in y, see how much it changed in y with this number and this number, and the same with the x, or you could look at it as y2 minus y1, etc. But I think this is the most direct route to this problem. Problem number 3. We have a table of x and y values. We notice right away that our change is constant. If it states in the problem that it's a linear relationship, then you know that this is constant. And if you have 20 values here, you don't have to calculate every single one of them. If they state that it is a linear relationship, all you have to do is find the difference between 2 sets here, or 1 set here and 1 set here. Okay. So we have change in y. Remember, the y value is always in the bottom. The change in y is 2. The change in x is 1. And we're done right away. 2 over 1 is our slope. Problem number 4. We have 2 points, point A and point B. So we're going to do the change, or we could call this change in y over change in x, because that's really what this is. But we're going to actually use the values. So we're going to use 4 minus negative 2 as a 4 plus 2. 5 minus negative 3 is 5 plus 3. And we get 4 plus 2 is 6, 5 plus 3 is 8. And we see right away we can divide both of these by 2. And we get 3/4 as our final slope. Problem number 5, another point problem. So we're going to take negative 3 minus 5, negative 3 minus 5. 3 minus negative is 3 plus 6. Negative minus a negative is even more negative. So it's negative 8, and 3 plus 6 is 9. Our slope is minus 8/9. So the reason that we want to leave it like this as a slope, think about this. You could see this line, it would be dropping 8. If we drew this line, it would drop 8 for every 9, so it would be at a slope at about like that. And number 6. The answer to this is that slope is the same as rate of change, and in a linear relationship, the rate of change is constant. Therefore, the slope would have to be the same throughout a line, throughout a linear relationship.